Good day. I am Francisco Guerra Bichido, and I'm going to talk about the article Method for Judging the Stability of Asphaltene in Crude Oil, written in 2020 and published by the American Chemical Society Publications. First of all, the precipitation and deposition of asphaltenes are drastic issues in the petroleum industry, and monitoring the asphaltene stability in a crude oil is still a serious problem that has been subject of many studies. This article in particular is about the colloidal instability index, which is applied with the composition of Sarah fractions. The deposition of asphaltenes is a well-known problem that generates a big cost increase in the petroleum industry. This phenomenon seriously affects the petroleum production and refining processes as well, because a small change in the petroleum components can cause the precipitation of the asphaltenes. The reason why this article was written is because oil field production is often accompanied with asphaltene depositions, and in China, based on a large survey of crude oil production, researchers made the conclusion that light oil is more susceptible to cause asphaltene depositions as in comparison to heavy oil. And I have said that asphaltene deposition is a serious problem during the production of crude oil, because when the asphaltenes precipitate and deposits in the reservoirs, they lead to the alteration of the rock surface and the deposition in the well tubing, and also the deposition of the asphaltene in the well tubing results as a plugging, and this affects the overall efficiency of the production and also add additional cost, which always is indesirable. The crude oil can be fractionated into four components, those we call SARA. SARA stands for saturates, aromatics, resins, and asphaltenes. By determining the proportion of the SARA components, we can calculate the colloidal instability index of the oil. And we know that the colloidal instability index is a method to determine the instability of an oil, which is based on the chemical composition of the crude oil, and it is calculated as the sum of saturates and asphaltenes divided into the sum of aromatics and resins. If the oil has a colloidal instability index value below than 0.7, it is defined as stable. And if the colloidal instability index is higher than 0.9, it is considered unstable. Correlation between asphaltene and the colloidal instability index. The asphaltene is the heaviest and most polar molecule in the crude oil. Even though sweet crude oil contains low asphaltene, this doesn't mean that it has a lower tendency to precipitate than crude oil that has a high percent of asphaltene, because I said that several researchers has shown that the crude oil with lower asphaltene content can also have a higher tendency to precipitate in comparison with those oils that have a high asphaltene content. The experimental section consisted in analyzing 5 samples of crude oil using a method called thin layer chromatography and flame ionization detection analytical method. It is used to provide a more reliable way to obtain the SARA components. The apparatus process in summary consists in oxygen and hydrogen flow rate ratio, which influences in the stability of the test results and causes a deviation PEX, so it shows the fraction of the SARA components. Here we can see the results from the production reports. As we can see, the sample number 3 has the higher percent of asphaltenes, but it does not have the higher value of the colloidal instability index, while the sample number 1, which has an asphaltene percent of 0.82, has a colloidal instability index of 7.89, bigger than the sample with 1.03% of asphaltenes. In this case, no sample has stability. All of them has a colloidal instability index way higher than 0.9. So all of them are unstable. The Sarah fractions are in a colloidal model where resins have a strong tendency to associate with the asphaltenes because of their opposite charge. And so resins are absorbed by the asphaltenes to become like a protective shield. When this protective shield of resins is removed, the asphaltenes lead to precipitate. So talking about the results obtained, we can completely trust on them, not because the colloidal instability index is not a suitable model for this kind of oil. It is for the reason that asphaltene deposition depends on various factors like changes in the pressure, temperature, production rates, compositions, and other properties. For that reason, the same five samples were analyzed using a Turbiscan lab stability analyzer. It was used to test the stability of the crude oil by adding different volume ratios of NF10 and the transformation ratio and the Turbiscan stability index of the mixture. It is in this process, it is important to use NF10 of a high percent of purity. I read that it was used 99.999% of purity, so it's very high. In this method, first, the crude oil is placed in a sample cell in a stable temperature. It was around 25 Celsius. And the emitted light, the apparatus emitted a light that passes through the cell, and in the next phase, a certain amount of N-octane is titrated with the crude oil in the N-octane oil volume. And there are used volume ratios of 0.1, 0.31, 0.51, 1.5, and 3.1. In the volume ratio of 3.1, it's where the precipitate showed. And here we can see as we can see, using the sample number 1 as an example of the asphaltene, in the present graphic, as we can see, using the sample number 1 as an example, the asphaltene start to precipitate when the ethane oil volume ratio is 1:1. Below this volume ratio, the asphaltene can exist in the crude oil as an stable component. This indicates that the asphaltenes are not in their saturation point in the crude oil. In conclusion, it was understood that asphaltenes molecules in the crude oil are stabilized by resin molecules, preventing the deposition of the asphaltenes, but also the study of the crude oil composition, which are saturates, aromatics, resins, and asphaltenes, demonstrate that the stability of asphaltenes in crude oil is a phenomenon that is related to the component's behavior, the percentage of each component, the influence of each fractions on other fractions, and taking in consideration also the changes in the pressure, temperature, and production rates. But it cannot be associated with only one of them individually. Also, it was determined that the results obtained from the colloidal instability index can only be used as a spot determination of stability. It can be only used as a spot determination of stability of the oil rather than a deterministic value. So we conclude that the Turbiscan lab stability analyzer it's a more reliable way for judging the stability of the crude oil, and this method reduces the level of mistakes present in the classical colloidal instability index determination method. Here are the bibliography of the article that I used for this presentation. Thank you very much for your attention.